Okay, so we're going to continue today and hopefully finish up SQL because that'll give us the entire time on Tuesday to do a review for the midterm next Thursday, week from today. Remember that format is in class, same place, same time. It's going to be a 25 question multiple choice exam. It's worth, I think, 5% of your final grade. It's open book, open note, open computer if you wish. You bring a required number 2 pencil. Again, we're doing it old school Scantron-like because the testing center doesn't allow open book, open note, open computer tests, as far as the website claims at least. So to continue from what we did last time, we started this goal here of creating a database to model films, directors, and actors. And we got so far as to create a table to hold film data and even inserted a few values here. I want to remind you what we did with that. We created a primary key, and again, that's going to be film ID. We're following this the naming convention that it's going to be named after the table, and then we'll slap an ID at the end. And you'll also note here that for my values for my table columns, I'm using a lower camel casing convention. This kind of matches Java, right? You have classes that are upper camel cased, and then you have fields in those classes that are lower camel cased. And that's why I've adopted this more modern convention, because there is a one-to-one correspondence, and there's going to be a one-to-one correspondence between your database tables and your Java classes. So I like to follow the same naming conventions because we're not going to cover it, but if you use what's called an ORM, which is an object relational database mapping system, then having that one-to-one correspondence, everything named the same, it makes it so much easier. But we're not going to, if you want to, there's a lab on it and a video on it. For Java, it's JPA using Hibernate. That's Java Persistence API. It's an optional lab later on. I think it's 10.5 if you want to get into it, and you can check that out. But anyway, that's our naming convention here. We should always use integers as primary keys because integer comparisons are exact and efficient. You don't want to go and do a comparison based on a super long string here because it's inefficient, and you get into character set issues. Is it case sensitive or not? Is your query case sensitive or not? Was the database set up to be case sensitive or not? I like to avoid all of those issues. There's no case sensitivity issue at all if you use an integer. We label it as a primary key. Not null, because if it were allowed to be null, there could be one record with a null key value, and that's not too useful. And we're going to let the database handle it for us by auto-incrementing that. In other words, we can provide it when we insert something. We just need to make sure that nothing exists with that key. But I don't want to do that. The database does a very good job at key management. I'm going to let it handle that for me. We decided on a title, which was a string of varchar up to 255 characters. We also wanted to do a runtime, which is an integer. And by default here, both of these things are allowed to be null. In other words, you don't have to specify a title, and you don't have to specify a runtime. Likewise, an EIDR is a varchar 100, but it's not allowed to be null. We're going to require that as a value when you insert data or update data. You can't update it to null or something like that. You can do another combination here. So, for example, maybe runtime, maybe you've made that optional by allowing it to be null or not null. Maybe you want to provide a default value, that if somebody inserts a record without that value, you could put in a default of 0 because we don't know, right? I'm going to go ahead and run this entire thing. Hopefully I'm still connected. Right, there we go. And you see now that when I inserted Titanic, I didn't specify a running time, so that default value was there provided for me. When we stopped last time, we observed that there's a problem here, right? That the EIDR, that's supposed to be a unique value. But I was able to insert 2 records here with the exact same EIDR value. So what I want to do is I want to address that now. I want to redesign this table, not completely redesign this table. Come on, close, there we go. Don't want to completely redesign this table, but I do want to put on what's called a constraint. I want to say that not only is the EIDR a varchar 100 and it's not allowed to be null, not null is also a constraint. You can't insert the null value or update it to a null value. But I want to I want to put in another constraint here that says that every value in the database for each record has to be unique. That's called a uniqueness constraint. So I'm going to put in a constraint, and the syntax for doing that is by simply saying constraint. Right? I do need to give a name to my constraint, so I'll call it, I don't know, unique EIDR. Right? There are ways that you can do this where the database will generate the uniqueness or the constraint name itself, but I'm going to go ahead and put in my own name here. And then it's going to be a unique constraint. Right? I want a uniqueness on the EIDR field. Right? Now I'm actually doing two things here. I'm putting a uniqueness constraint on it so that nobody can share the same EIDR value, but also I'm putting an index on it, because if I want to search through this, then I want it to be indexed. I want it to be sorted in some way. And if you remember back to last semester, you saw the benefits of sorting. If a list of integers is sorted, what can you do to it? And you want to find the value 10. And if you have the guarantee that it's sorted, what algorithm can you use on that? Binary search. That's exactly what databases want you to do. If you were going to do a bunch of select statements based on like an NUID or an EIDR or something like that, then that means that you're going to be searching that database based on that column a lot. And if you're going to be doing that a lot, then you want to have the database maintain a sorted version of that so that it can actually search through efficiently using binary search or something else like that. Okay? That's the basic idea. It doesn't necessarily use binary search because the data structure that it's using are B trees or something like that, but that's the same basic idea. By putting by putting an index on it, we're basically telling the database, keep a sorted version of this for efficient lookups. And then the uniqueness is, I'm going to want a uniqueness on that index. You can put a uniqueness or an index on multiple columns at the same time with a comma delimited value list, so runtime, right? Or runtime, right? And so you can put it on multiple columns at once if you want a combination of those columns, right? So the combination A and B, there can exist no other record with the combination of A and B. You can have A and C, or C and B. You can have those combinations because those are different from A and B. But that you can have a pairing or a triple or some tuple of uniqueness constraints on multiple columns if you really want to. In this case, I don't want to because I don't care if the running time is fixed, right? So let's run this again, and we'll see that it actually fails this time. Right? You see that down at the bottom there? That last insert right here failed because I inserted it with the same EIDR value. I already looked it up here. Titanic has this actual EIDR value, and so we'll go ahead and insert that instead, ensuring now that they're unique. And when I run this version instead, now it works perfectly fine. And they both have two different EIDR values. Okay? And once again, as a review, the EIDR is not our primary key because it's an external key. We have no control over it. If we have no control over it, then we shouldn't allow it to control our database. Right? And so I'm putting a uniqueness constraint on it to ensure that it's unique, and it's a unique identifier, but it isn't the identifier for our database here. Okay? All right, that's a pretty good start. Let's go ahead and get rid of this. Now, as a second step in this phase here, we're going to have to create a support for directors, right? One way that you could do that is you could come back up here to this film table and just simply add in a director. What is a director, though? Who directed Titanic? I think it's down at the bottom here. James Cameron, right? So we want to insert that James Cameron directed this movie right here, right? And who directed Dune? Oh, nobody knows. David Lynch? Right. Oh, no. Definitely David Lynch. I love that movie. All right, so what we could do is we could put in a first name, last name, right? James Cameron. So we could put in director, first name, right? And it's going to be a varchar. I don't know, 100 is big enough for most first names. Director, last name, varchar 100, right? But does that seem like a good design there? No. First of all, what's going to happen when we insert, he also directed Terminator and Terminator 2, right? We're going to have James Cameron, Avatar, and Avatar 2, or whatever else he directed. We're going to have James Cameron everywhere. We have redundancies, right? That actually violates what's called first normal form, where we want to actually separate this out into another table so that we only have one entity known as James Cameron, and then we can associate him with these 4 or 5 movies over here in this table. We want a one-to-many relationship between those two things. So let's not do it this way. All right. Let's go ahead and create another table for directors. Create table, director. Right. And again, I'm following the convention that I'm going to have upper camel casing, just capital D, director. And I'm not going to pluralize it. It's not the directors table. It is the director table, and it holds director records. Right? What's the first thing I should do? Yep. Primary key. Primary key, director ID, integer, primary key, not null, auto increment. That should be should be the first thing that you do on all of your tables to ensure that you have some way of uniquely identifying all those records. You don't have to put in a primary key on any of your tables, just like you don't have to design your Java classes well. You can do whatever you want, but that doesn't mean that it's going to be a very good design. I've seen plenty of databases out there with no keys at all whatsoever. And it's been a nightmare because there's no integrity, there's no consistency, and it just leads to a big, huge mess. Okay? So I've got the director ID. What else do I need? Probably first name, right? Which is a varchar 100, I think I said. Last name, varchar 100, right? That's pretty good. We could put in a Directors Guild identifier or something like that, if there even is such a thing. But I'm going to go ahead and leave it like that for now. Note that I didn't call it director first name. Why? It's because it's the name of the table. Director and then a first name. Right? I don't need to do that. Okay. Let me go ahead and create this now. All right? And everything works. But is there I've got a film table and I've got a director table. But is there a connection between the two yet? No. And in fact, I'm going to show you a trick here. Did I say I need to cancel? Oh, okay. Save. I'm going to save this as temp for now because I want to show you a trick. And unfortunately, you're not going to be able to see it because it's on the other one. But if you go up to File, New Model, that's going to create a new model here. Then File, and then there's an option to import and then reverse engineer a MySQL script. Let me go ahead and open this up. I called it temp. And I'm going to make sure that I check this box, and I'll come back to this and show you it again. And I'm going to execute this as it continues. Yeah. Oh, great. What did it just produce for me without me having to do anything other than a bunch of button clicks? This is an entity relation diagram, right? This is a diagram that is going to be really, really helpful in your design document once you've got everything. You can come up with a design on paper first, and then you can go, once you've implemented it, then you can have a nice diagram that looks something like this. You can move it around, and then you can export it as a PNG or something like that. But you can see here that I've got 2 tables. They're completely described here. The director ID, there's a nice little key there, right? I can't zoom in, unfortunately. And just increasing the size does not zoom in either. But there's a little key here. The diamonds there, whether or not they're filled or not, tell you whether or not they're allowed to be null. But the first thing that you can see here is that there's no connection between these 2 tables like you think that there should be. Right? A director directed that film over there. These 5 films were directed by that one director over there. I want a one-to-many relationship between those 2 tables. I'm not going to save that for now because we're going to be making changes here. So parent-child relationship. I've got 2 tables. What's the parent and what's the child? Who's the parent? The director. The director directed these 4 films, right? You have multiple children that you can refer to. So therefore, if I've got the director and the films down here, where do I need to put my foreign key to reference back to the to reference back to the director that directed it? I need to put it down here in the child table. right? So I need to put in a foreign key here that references the director that directed it. What if I did it over here? What if I put in film ID? Right? What if I put that there? This director directed that one film. James Cameron directed Titanic. Titanic has an ID 2, say, right? How am I going to get that James Cameron directed Terminator? Another record with James Cameron repeated, and then Terminator is number 3, or is ID 3 or something, right? Yeah, we'll talk about that. Yes, that is even worse. So I do want it up here, okay? Probably put it down here. Oh, again, order doesn't matter. I like to put the things that relate to the film first, and then the things that relate to other tables second. You could even put it after the... sometimes I put all the constraints at the bottom to collect them all. But let's go ahead and put in director ID. Right? This director ID is going to refer back to this director up here. So we've got a films, and then the director up here directed these films. So what type should it be? Should it be a varchar? If this thing is going to match this thing, then what should it be? An integer. Right? Should we allow it to be null? No, what does that mean? This director, or this film right here, Terminator, was directed by the director null. Right? You could have that. If you're allowing it to be null, then that means that you're allowing what? Children with no parents, right? Orphans, whatever you want to call them, right? So I'm going to say that it's going to not allowed to be null, right? And I will go ahead and leave it like that. That doesn't define a foreign key yet, or that doesn't define a foreign key yet, right? If I execute this, this will execute probably just fine, except for these inserts will fail because I'm not providing the director ID. So let's go ahead and run this. Yep, those inserts. Oh, it was just a warning. Weird. Director already exists. What do I need to do? Come back up here. Drop table if exists. Director. There we go. We'll come back to the ordering on these in a moment. But these are actually given just warnings because that's kind of weird because there's no constraint on it yet, right? So it's not allowed to be null. I don't know what values it actually has. Select everything from film. Okay. It ends up giving it a default value of 0, even though I said it was not null. So apparently, it's putting in default 0 here for me, even though I probably don't want that. Okay. What I want to do is I want to say that this director ID has a connection to this table and this column in that table. And the way that I do that is simply foreign key. Right? It's not a primary key. It is a foreign key. Right? And I need to give it a name. I need to give it a reference. Which one of these things is your foreign key? It's my director ID. Right? And what does it reference? Well, it references the director director table and the director ID in that table. Right? And that's the syntax there for creating a foreign key. It's a foreign key. You have to tell me, well, which one of these things do you want as your foreign key? And by the way, you could have a comma delimited list of something, I believe, though you shouldn't do that. And what does it reference? Well, it references the director table and the director ID in that table. Okay? So let me go ahead and try to run this. Let me go ahead and clear this out. Oh, it failed. You can't read that, but you can't create table film. Why? Error number foreign key constraint incorrectly formed. Right? What's wrong here? Yeah, I've got a foreign key here called director ID that is referencing this table. Well, guess what? That table has to exist first. Just like you remember that, what's the example that we've been using so far? The what? The other example. The video game database. That's it. That a publisher and a game. A publisher has to exist before a game exists. A parent has to exist before the child exists. Well, that's the same with the table. If you've got these tables, this table that references that table up there, that table has to exist first. So if I'm going to do this, I need to bring this up. I'll bring up the comment too. To up here. There we go. And I'll run that again, and it still fails. Cannot add or delete a child row. We'll understand why here in a second. Let me go ahead and clear this out. But before we look at that that error that just occurred, if I have to create it as a director first, then a film, then what order do I have to destroy them if they exist? Can I do it like this? Can I destroy the director first and then the film? The film references the director. So if I create it director then film, how do I have to uncreate it? I have to go in reverse order. So I have to do it as film then director. And that's why it worked the first time. Right? Let me go ahead and run this again. And it's complaining down here on this line right here that, well, wait a second, you've inserted this film, but you didn't give it a director ID. You didn't tell me who directed this film. A child cannot exist without a parent. So you can't create the child before you create that parent. So I need to create a director. Insert into director, first name, last name, values, James, Cameron. Right? There we go. And the other film that we've got is Dune. So let me just go ahead and cut and paste here. And that was David Lynch. Good. Lynch. Right. Well, okay. Maybe for a particular cut. I'm not sure, but let's see. Oh, and then now what I need to do down here is I need to provide the director ID, right, and this director ID for Dune and Titanic. I don't know what those are though, right? If I could go ahead and piecemeal run everything up to this part, right? And then I could select everything from director, right? And I can see that James Cameron is going to be 1 and David Lynch is going to be 2. And so I could go ahead and hard code those values, right? What is it? 2 and then 1. There we go. And go ahead and get rid of this. And go ahead and select everything. Now it works. But that seems kind of fragile, right? What if I went ahead and changed the order of this stuff right here? Is it going to be 2 and 1 anymore? It's going to be 1 and 2 now instead of 2 and 1. So one way that I could do this is I could do it as a subquery. Select the director ID from director where first name is equal to Dave. Wait, which one am I on? Titanic. So James, and last name equals Cameron. And I'm still going to be crossing my fingers here and hoping that there aren't 2 directors named James Cameron, right, in the future. But it still works, right? So another way that I could do this, though, is if I'm not really into these subqueries here, is I could go ahead and hard code those keys. So director ID, I'm going to specify it as, say, 10. Right? For your test data, this is perfectly fine. For actual data that's in production later on, you probably don't want to do key management on your own. But for test data, yeah, sure, go ahead and insert it as 10. And then that way, David Lynch directed Dune, and you're good all around. Right? You can use both of them. By the way, what director ID did James Cameron get because he was inserted after David Lynch? What was the next one? 11, right? That's that auto increment taking care of it for us. Okay?
Is there actually a way, without doing that, to tell the auto increment to start at?
That would require you to set a value in the database metatables, but yeah, you can. The question was, can you reset the value at which you start? Yes, but that's a DBA thing. You're going to have to go in and update a table. And quite honestly, I don't know whether or not you have access to do that on CSE. But if you have your own database that you've installed on your own computer or whatever, and you're admin, you can do whatever you want. Right? Okay. All right, that's pretty good for now. Well, let me go ahead and regenerate that, the ER diagram. Remember, it was File, New Model. That creates a new model over here. Then I go back to File. Again, it's on the other screen. Import reverse engineer script. I will open up the same script. Oops, I don't think I saved it. Oh well. We can come over here and save. There we go. And then I'll do the same thing again. File, import, reverse engineer. That temp script that I saved, place imported elements on the diagram. If you don't do that, it won't generate the ER diagram. You'll have to do it manually afterwards. Execute this. Continue. Yes. Close. Ooh, and now, what kind of a relationship do we have between these two things? There is the single relationship over there, and then there's the chicken foot, right? The chicken foot tells you that there's a one-to-many relationship between the director and the film. You can put it up here to emphasize that parent-child relationship, or make it look as pretty as you want, right? You can actually even design your database like this. I think if you double-click this, you can come down here and change it, and then you can actually generate the SQL that would be needed to create that database. I've been showing you the SQL, and then it generates the ER diagram. You can work in reverse. You can visually create your database and then have it generate the SQL code for you, right? But I think that that's at least when you start out with SQL, and it's going to be much better to actually go through the process of the SQL statements, right? All right, don't save that. So we've got films, directors. What else do we need to do? Actors, right? So let's go ahead and create a table for actors. Right? And you might have to help me here because I don't know who acted in Titanic. DiCaprio, right? Leonardo DiCaprio. Okay, and who else? Billy Zane, right? Yeah. All right, good old Billy. All right, create table. I'll call it actor. Again, not actors, because it's a single table. What's the very first thing I need to do? A primary key, auto increment, not null, called actor ID. Good. And it's probably going to be very, very similar to director up here. I'm just going to go ahead and steal that. First name, last name. Maybe we could put in a SAG card number or something like that. I don't know. We could put in... I don't know, where they were born, a birth date or something like that. I'm going to keep it simple like this for now, right? But you might be thinking to yourself, wait a second. I have two tables, one called actor, one called director, with the exact same stuff. Maybe there's a way that we can make that a little bit more efficient in the second version of this, okay? But for now, I'm going to go ahead and leave it like that. What's the relationship between an actor and a film? Let's say what? So an actor acts in a film, and from the perspective of the film, an actor stars in a film, right? But as we already said, Titanic had 2, 3, 4 actors, had many, many actors, but we're going to focus on maybe on 2 or 3. In other words, there are many actors in a film. Now, Leonardo DiCaprio, did he only act in one film? No. Billy Zane, maybe. But no. No, all of those actors have been in multiple films. So what kind of relationship do we have between those things? A many-to-many relationship. Just like with the video games, if you've got a video game and a platform, one video game can appear on multiple platforms, and one platform hopefully has multiple video games on it. So what we need in the center is a join table that brings those two things together. I'm going to go ahead and call that, what should we call that? Acted in, right? Sometimes, or starred in, I don't know, starred in, that might be generous for some actors. Acted in, or was in, or something like that. I'll just go ahead and go with acted in. There is a strong temptation among a lot of people to instead, if you're joining table A and table B, to call them A, B. So it'd be something like film actor. Right? That actually makes sense in this case. So I'm going to actually go ahead and leave it like that. Right? All it's saying is that that this film has this actor, and I'm bringing these two tables together. I'm joining them together. Okay. What's the very first thing you should do? film, actor, ID, integer, primary key, not null, auto increment, right? That should be the very first instinct that you have. This needs a primary key, right? How do I bring those two things together? I need to refer to two foreign keys, right? I need to refer to the actor ID of the actor that acted in that, and I need to refer to the film that they acted in. Right? Both of those are going to be integer, right? Not null, right? And integer, not null. There we go. Okay. And I now need to define two foreign keys. So I'm going to go ahead and grab this syntax up here and adapt it. So the foreign key, the first one is the actor ID, which is going to refer to the actor table. And the second one is foreign key is going to be the film ID, references, film. And again, the following a good naming convention means that I have no guesswork here whatsoever. It's the film table, and I know that it's the film ID. Right? I didn't have to go up and look, oh, what did I type again? Right? Because I'm following a consistent naming convention for all my keys. Right? Okay. Are we good putting this last? It refers to two tables, the actor table and the film table. Those tables have to exist first before I create this join table. I already did them up there, right? So putting this last is exactly where it needs to be. Right? I also need to take care of drop table if exists, if I'm going to be running this multiple times. What order should I do this in? Film, director, that's straightforward. What about actor and film actor? If I created director, then film, then actor, then film actor, and I need to go in reverse, what should I do first? Drop table if exists, film actor. Right? Drop table if exists, actor. There we go. Now, actor versus a film versus director. These, at least with respect to actor, I could move this down. Right? I could move it down here or here. I don't want to do it multiple times. But that one doesn't matter with respect to the other two because it has no direct relationship between them all. Okay? Let me go ahead and run this. It should run well. Yep, there we go. But I don't have any actor records, so let's go ahead and rectify that. Okay, so let's see. Let's go ahead and insert some actors here. Insert into actor. Value, or here we go, actor ID, first name, last name, values, and here I am going to hard code them simply so I don't have to rewrite all those subqueries. I'll say that actor 1 is going to be Leonardo, and then DiCaprio. Correct? No? Doesn't matter. Who cares? Let me do some more actors here. Who else? Billy Zane. And who else was in it? Kate Winslet. Okay, fine. And then we can go ahead and associate all three of those actors to that the Titanic film. So insert into film actor, actor ID, film ID, knowing that the film actor ID here is going to be taken care of for me. Values, 1, and then what's the Titanic? 11. Oh, okay, it's 11. I'm going to go ahead and hard code that then so I don't have to do this. All right. I will leave this here, though, for you so that when I post this in the notes, oops, okay, you can see it, right? And then, say what? Oh, darn it. Okay, we'll leave that then in there. The film is what? 2? But I started out at where did I insert the films? Directors, then films. I don't specify them there. Okay, so I should. Film ID and film at least for these two. I'll have to specify them as I don't know. Here's an old basic thing, 100, right? Because what happens if I want to come back and say Okay, well, I've got 10 more that I want to add. So you start your numbers very large and with huge gaps in between for your test data. This is because it goes back to the days of BASIC. The BASIC is a programming language. The way that you programmed this was by putting in line numbers. So line 10, and then you had your line of code. Line 20, you had another line of code. You didn't have to skip tens, but that was usual because what happens when, I actually need to add a line between those two lines up there? Okay, well, that's fine. You can put in 15, right? So you all went by tens here so that you could come back and change it. It was maddening because, of course, even having line numbers, that was a terrible design language to begin with, but that was the workaround. And so I'll use that workaround here of having a film ID of 200 for Titanic. And so I'll insert 200 here. And then likewise for the other two actors, 2 and 3. Okay, that looks good. Let's go ahead and insert a few more let me go ahead and run this to make sure that it actually works. Clear this. Otherwise, we'll have to come back and debug it. Uh-oh, what's wrong? Column count doesn't match column on row. Insert into director. Oops, I screwed up when I erased that. Uh-oh. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. I don't see where. Darn it. And the director is wrong. 11. Oh, there. I didn't mean to put that in there. There we go.
You may need to put it in the other one as well.
Oh, okay. Director ID, and then director ID. There we go. Fine. There. Now it's perfectly fine. Okay. I fixed everything, but before, come on. All right. Give me some more actors here. Insert. Well, here I just want to cut paste. Insert into actor 4. Who starred in Dune? Anybody? Okay. Actually, that's a good one because it kind of tells us, what happens when we've got somebody that doesn't have a last name, at least officially? Right? We can look it up and see what his actual real name is. But Sting was in it. Sting is one name. Is that his first name or is it the last name? Maybe in real life we need to get another table to handle that kind of like preferred name, displayed name. It's aliases going back 20 years, right? Let's forget about Sting for a second. And who else was in it? Patrick Stewart. Who else? Good. Wow. You really know this movie. Brad Dourif, right? Also played the voice of Chucky. Right. I'll go ahead and leave those two. Right. Good. All right. And let's go ahead and insert into film actor. What's the value for Dune? 100. And Patrick Stewart and Brad Dourif went ahead and starred in those. Let me go ahead and save this, run it. Everything works fine. But as a last step here, I want to show you that all the data actually is working together by having one big giant join statement that gives me all that information that I've just inserted. So I'm going to select everything from, where should we start? Probably at the top, director, D, join film, F, on D dot director ID is equal to F dot director ID. Then I'll join that to the film actor table on F dot film ID is equal to, I need to alias this, FA dot film ID. So now I'm over to 3 tables, and I'll join that yet again to the actor table, A, on FA dot actor ID is equal to A dot actor ID. Right, there we go. And I'll just select everything out. Right? And we'll go ahead and execute this. And I see all that stuff there. Right? Leonardo DiCaprio, Billy Zane, and Kate Winslet were all in James Cameron's Titanic. And I've got David Lynch's Dune here with 2 actors. Right? So I've got basically a full-on database here, similar to the video game database, but instead we've got it for films. Right? In fact, it's exactly the same, intentionally. Right? Let me go ahead and as one last step, let me go ahead and create that new model. I will import and reverse engineer that script. I saved it this time. And I will place those imported objects onto the diagram. And now it's going to be much easier to reason about this, right? Rearrange it. It doesn't know what the best arrangement is. But there's the director going to the film, right? Showing a clear one-to-many and one-way relationship there, one-to-many relationship, with a film actor table sitting in between a many-to-many relationship, okay? You can go ahead and rearrange them like this if you really want to, or you can play around with it and just make it look as pretty as you want, right? Any questions on this so far? No? Okay. I will make that available, of course. Let me go ahead and come over here back to the traditional notes. I should have launched this to begin with, sorry. Open new window. There we go. And come on, there we go. All right. So good demonstration of querying databases and I'll go ahead and copy that later so that when I post it, it'll be available. But normalization. This is something that we were doing implicitly without me actually saying what we were doing. Basically, it's common sense to reduce redundancy. All you have to do is think about what you're trying to model and what the real-world relationships are between those two things. A director directs a film. Now, you can, in the real world, you can have multiple directors. Sin City had 2 or 3 directors, I forget what it was. But you can have multiple directors on one film, and one film, of course, or one director can direct multiple films. That's not how we chose to model this this problem. But of course, we could do that by providing a join table in between them, right? The idea was that we separate things out into other tables. We reduce redundancy, and we make sure that we don't have any room for data anomalies. And that the formal process of that is called normalization. In fact, there are three normal forms. Actually, there are more than that. There's 1 normal form, 2 normal form, and 3 normal form. But those are the only ones that matter for this course. If you want to get into database theory, there's 4th normal form, which is, I think, temporal normalization, that you have a database snapshot at today and then the database snapshot tomorrow. What's the relationship between those two things? We're not going to worry about that. Right? Our database it will change over time, but we're not going to worry about the relationship over time. So first normal form is how should I put it here? Let me go ahead and grab this. There we go. So first normal form is that each attribute in a table has only atomic values. Atomic being indivisible, right? Atomic meaning that you can't break it up any further than it already is. And rather than we basically did that, but rather than tell you what you should do, it's much more helpful to show you what you should not do, right? What is a violation of first normal form, right? Having a comma delimited column, for example, right? If I want to support multiple emails, say I've got a student or I've got a director's emails or something like that. If I wanted to support the fact that you have 1 email, 2 emails, 3 emails, 50 emails, what I could do, one thing that I could do is just have one giant varchar column, 1 column, emails. And then in that column, I'll store all the emails delimited by a comma, right? That's going to be terrible because there's no structure to that at all. There's no difference between that and what you've been working with on your first few assignments of the CSV file. CSV files are flat data files. That takes us all the way back to the very beginning where we pointed out all the problems with CSV flat files, right? If you're going to use a database, you might as well use the database. Don't just use a database to do the same thing that you've been doing, right? So a violation of first normal form would be having a comma delimited list of values, or also a violation fixing a number of columns, say 3 email columns, right? And I've seen this before, and you do have a little bit, they had, at least the people I argued with about this, they had a little bit of an argument here that, well, reasonably, nobody's going to have more than 3 emails. Everybody forwards to 1 email or something, and we don't want a whole nother table and a whole nother join table to model that. It's inefficient. We're going to have to write so many more queries, and the whining went on and on and on until I said, all right, fine, go ahead and do what you're going to do. And they fixed it to 3 email tables. The drawback to that, though, is what if one person only has 1 email? What about those other 2 columns? They taking up they may be taking up needless space. I'm not. If they're varchars, it's probably 0. There might be like a null reference there, but they take on default values. They take on, say, null or the empty string, right? And now you're back at square one. You got to process that stuff anyway. Oh, how many emails do they have? Oh, the first one, that seems valid. The second one, no. Oh, okay, they only have 1 email. Oh, wait, they had an email on 1 and an email on 3, but not an email on 2 because we don't have first normal form here. So you have to process them all anyway and say that this is a valid email or this is not. And then you get into the formatting issues, again, the CSV files provide. Right? So stay away from that. Have first normal form. If you find yourself having that this entity has multiple of these entities, right, there you go. That's your separation. You need 2 tables at least. Maybe if you've got a many-to-many relationship, you actually need 3 tables. But that's first normal form. Second normal form is that first of all, it's transitive, so it has to be first normal form. But it's first normal form and no non-prime attribute is dependent on any proper subset of prime attributes. And what that means in practical terms, let's see, is not that. Let me back up on this. That let me put in the practical aspect here. If you use auto-generated keys, then you are to normal form automatically. Right? It's not something that you generally have to really worry about if you are following good practices and put auto-generated keys on everything. Basically, I guess what's the classic example? Do I even have a classic example here? No. Darn it. A purchase record. A purchase record, example. A purchase record may contain a customer ID, a store ID, and a store location. Right? So consider those 3 pieces of data. Right? There's a purchase transaction here from a customer, and that customer has an identifier. A store, and he purchased it at a particular store, so that store has an identifier. And maybe those 2 things together, that constitutes a key, because this one person bought this thing at this store. That makes sense. But it doesn't make sense to store the store location, right, their address, in the same table. Because what does a store location have to do with the customer itself? Nothing. If you know that the customer purchased it at a particular store, then you can look that information up in a separate table. Don't store that in that same table. Store it in another table. And again, if you're following first normal form and separating that out to begin with, and then having auto-generated keys, then you don't. Then you're already conformant to this idea. Right? And then third normal form is that no non-prime column is transitively dependent on the key. Right? And what that means is, and more apropos to your assignment here, suppose you had a price per unit, and a number of units. Right? Then what's the total price? Is equal to what? Price per unit times number of units, right? it would be a violation of third normal form to store total price. Right? Why? Because it's transitively dependent on the other two. The price per unit and the number of units, all you need to do is multiply those together and then you get the result. You don't store that result. You can always recompute that result in a query or in your program or something like that. You don't store that result because it can lead to data anomalies. What if I'm buying 10 Cinco phones at $50 each? The price today is $500. If I store that in my database, $500, then tomorrow now they're half off, right? Is that $500 correct anymore? Nope. I would need to recompute that value anyway, so you don't store it. If you have a use case where you had to say, take a snapshot, that today this is the invoice value, right? Then you would generate that invoice and store it some other way, not in your core database, right? You would have probably another table like actual invoice or tentative invoice and then historic invoice, and then you'd have to have a timestamp on your invoice if you were going to store all that stuff, right? And even if you did that, you would store the price per unit and the number of units on that day rather than updating it. So you'd still not store the total price because it could be recomputed from other values in the table. Okay. The bottom line here is that third normal forms are common sense or intuitive, right? As long as you're thinking about what you're trying to model and the relationships between those two things, just like you designed all of your tables, then you'll be fine. Right? And another way that you can remember this is that every non-key attribute must provide a fact about the key. That's first normal form. The whole key, that's second normal form. And nothing but the key, that's third normal form. So help me COD. Right? So I swear to tell the truth, the whole truth, and nothing but the truth, so help me God. That's the mnemonic device that's used often for third normal forms. Every non-key attribute, in other words, all the columns in your table other than the primary key, they have to provide a fact about the key, the whole key, and nothing but the key. So help me, who's COD? You remember? He's the guy who invented relational database management systems. Edgar COD from IBM in 1970. Right? So make sure that you are following those best practices. Right? Let's see. As a wrap up here, there is a lot more to databases to learn. For example, you can have triggers, views, stored procedures, etc. SQL, I believe, is Turing complete in that you can write loops if you really want to. There are cursors to do this, or some databases allow you to actually syntactically use a while loop or something like that. You can put entire functions into the database, and then you can call those functions as if you were querying out the database. You can create views. I'm working backwards here, sorry. A view is a way that you can access data but not update it. So it's a way to restrict access to certain users, right? If you've got a program that comes in and updates data, inserts data, that's fine. But if you've got a consumer of that data, a program that just displays stuff, then why would you need to give them read and write access? You just give them read access. And if there's a particular column in a particular table that's sensitive, like a GPA or a social security number or something like that, you can restrict that from the view, so that you can get first name, last name, and enrollment data without giving away account information or something. And so you can create views like that and give those out as much as you want. It's a read-only access. Any attempt to update or change that, it's not a real table. So any attempt to insert data like that on that view is not going to work. And of course, security, you can, I think that on our CSE system, you can access it from off campus, I think. In fact, they had to fight ITS to keep port 3306 open. ITS wanted to close that port on their university firewall, and we said, no, we got a lot of students that work off campus. They need access to port 3306. That's the MySQL port. So they've kept that open for us, thankfully. But you could restrict that. You could say that this person is allowed to access this database, but only from this this IP address. That way, you can create basically a secure network that your application server is going to be accessing a database server, and they're completely separate, but they're in the same network. Well, first of all, you firewall it out from the rest of the world, but also you say that your application server can only that this database can only be accessed from this application server, which has a particular IP address. It's a very easy way of securing stuff. Finally, triggers are something that you can put into databases that say the only use case, one of the primary use cases that I've seen of this is where suppose that you want information on when this record was last updated. You could put in a trigger there that on each update it actually goes out and puts a timestamp into a particular column, the last updated column or last date updated column, and that trigger will trigger for every time somebody inserts or updates data for that table. You can put a bunch of triggers. In fact, you can have cascades where where say that you delete a director record, right? Normally you couldn't do, or you want to delete a film record. Normally you couldn't do that without first deleting the director and any actors that acted in it first, or at least the actor film record. You could put in what's called a cascade that says, I know what I'm doing. I'm going to go ahead and delete that, and I want you to go ahead and take care of everything for me. Delete all of those records permeating throughout the rest of the database. Those are cascades. All right, they should call them avalanches because they're way too dangerous to use. I would not recommend that you do that. Right? Question?
So triggers are basically like stored procedures that run every time data is accessed.
Basically, yes. Or on certain events that you can define, right? Or on cron jobs where they run every night or to back up a database or something like that. Actually, that wouldn't be done with a trigger. That would be done with an actual cron job. But that's the idea, right? So there are lots of other things in databases. Security. Like, for example, don't store passwords in databases. All right? Never store a password, at least unencrypted, unhashed. Right? Right. Not 3 months goes by that you don't hear about somebody's database being hacked and a bunch of passwords being released, right? The most famous recent example of this was, what was that cheating website? Ashley.com, something like that, right? In fact, in that situation, they hacked the database, they got a bunch of usernames and passwords, and then they held it for ransom. They went to the company that was running it and said, we've got all your data, we're going to release it unless you pay me $1 million in Bitcoin or whatever ransom they were demanding. They didn't, and so they eventually released their data, right? And so all of these people who had signed up for a cheating website had now been exposed. Not only had they been exposed, but all their passwords had been exposed. They weren't unencrypted, but I believe, and I don't recall 100%, but there have been plenty of examples like this. There are plenty of examples where either they store it plain text in which all your passwords are out there now, or they stored it with a stupid hash like MD5 or even just plain old SHA-1, in which case you can now use what's called a rainbow attack or rainbow table attack, which is basically a dictionary attack that a lot of take the 10,000 most common passwords, hash them with whatever hash value they've got, and now you've got all. If they used a commonly used password like password or 1234 or something like that, or some variation thereof, now you've got all their passwords. Not a month goes by that you don't hear about a break-in like this. Don't store passwords unencrypted or unhashed, I should say. Yeah. Yeah, that's another best good. I don't know if it's best practice, but it's good practice. You're kind of shifting the trust. You're shifting the trust over to like a single sign-on thing like Google or GitHub, right? You go to a website and you can see, oh, you can sign up with your Facebook password. All they're doing is handing the authentication off to a third party, right? It's really how much you trust that third party. How much do you trust that Google is not storing passwords with a poor with poor hashing algorithms? How much do you trust that there's not some malevolent Google employee that is not thinks they're not getting paid enough, and so then says, all right, screw this, I'm going to go ahead and dump my database and give it to some hacker over the seas that has no jurisdiction and no extradition, and then they can go ahead and share the Bitcoin with me after they pay the ransom, right? So it's just shifting the responsibility over to a third party. How much you trust that third party, that's a call that you would have to make in those kind of design things. Also, you'd probably want to consult a lawyer if you're big enough, because if Google does screw up and passwords are released or whatever is released, does that mean that that you can sue Google? Maybe, maybe not. If you look at the fine print on their usage, they probably have an indemnity clause that says, nope, you can't sue us. And now you're left holding the bag when all the users sue you instead. Again, this is not something you have to worry about with small projects. Nobody's going to sue somebody without a lot of money. They would want to sue Google, who does have a lot of money, right? There's also some other best practices. For example, like hard versus soft deletes, right? So for example, a hard delete means you actually delete from a record. Delete a record from the database. Remember, I said there's no undo button. That's a hard delete, right? Versus what's called a soft delete. Soft delete, every record would have an active or is active column, which would be a Boolean. They do support Booleans, which are just basically tiny ints. 0 is false, 1 is, and anything else is true, I believe, but I think it defaults to 1. And so what you could do to delete something would be to set that is active to false, right? Nice design, because nothing ever gets deleted, and you can all, somebody calls you up and says, oh, I screwed up, I deleted everything, right? I deleted this essential record. Is there any way that you can save me? And you go, oh, okay, I'll see what I can do. Give me 24 hours, right? And then you sit there and you sit there for the next 8 hours playing video games or whatever. Then you call them up and say, then you set that flag from false to true, and then you call them up back. It took me all day, but I was able to actually restore your record. So congratulations, right? You owe me, right? So you can go ahead and be the hero if you've got a way, if you use soft deletes instead. In practice, you don't have to adopt one way or the other for your project. We're not going to require soft deletes or anything like that. But it's a nice way of making sure that not everything gets deleted. Having regular database backups would mean that you could go back to an older version and restore it anyway, but that's going to be a lot of manual work. Or you could use a tool to do it. Or having soft deletes. Now, the cost of that is that in all of your queries, to pull out the current information, you're going to also have to specify that is active is true, because you don't want to pull out all the records, all the soft deleted records. So it does come at a cost of a higher complexity on all of your queries. But those are some other good practice tips. Again, following the best practices that I've told you, good naming conventions, consistent naming conventions, making sure that you always have a primary key, making sure that if you've got two tables and they're related, that you have a foreign key, all those things, and of course security and other things, all those should follow best practices. I don't cover triggers, views, and stored procedures simply because, well, one, there's not enough time, and it's an introduction to databases. It's not a database course. But you can go ahead and get into them if you want. In practice, though, I try to stay away from them as much as possible. Because as you're going to find out, you've got, we're going to talk about like multi-tier architecture, where you've got a presentation layer. That's what an end user actually sees. You've got a middle tier layer, which is where all of your business logic should be. And then you've got a data layer. And all of these things, all three of these things are talking to each other. Sometimes it's given as what's called an MVC, Model View Controller architecture. you don't want to mix responsibilities. The presentation layer is responsible for presenting data. The data layer is responsible for storing data. And the middle tier layer is responsible for executing those business logic, right? A consultation costs so much money per day, and all that stuff, that belongs in the middle tier. That doesn't belong in the database. That's business logic. Databases are for data, not business logic. Middle tiers are for business logic. But by overusing stored procedures, sometimes you get that business logic too much into the database. And if it's too much into the database, then you don't have what's called loose coupling. You can't come in and say, have two teams that work independently. Now they're stepping on each other's toes because the database team is responsible for business logic, and now somehow the business logic tier or the middle tier people are responsible for the database layer as well, right? It doesn't work out very well in practice. Keeping loose coupling, keeping strict boundaries between those things really helps design, right? All right, any questions? Any questions about Lab 7? Hopefully everybody is able to do it on their own. I would highly encourage you to do it, even though I gave credit for everybody because of the snow day, you really need to go through those yourself in order to be well prepared for future labs, and your project, but also for the midterm next week. We do have SQL on there, like 10 questions on SQL. Okay. All right. On Tuesday we'll come back and I'll just have it up here on the overhead projector here. We'll do as many multiple choice questions as we want.